Hey, thanks, Kate. And thanks, everybody, for joining us today in our ongoing webinar series on data integration practices. Today, we're going to be talking about moving data to the cloud, specifically AWS, and doing it reliably and efficiently. I imagine most of the people in attendance today are already committed to moving to AWS or have discovered, why it's a good idea. So I'll treat the motivation, fairly briefly, right? I think we all understand the value of going to the cloud and going to AWS. Most of us have, we're established, mature organizations, but we'll have some legacy system that's critical to our success, right? The good ones may have served us quite well for years and allowed us to concentrate on running our real businesses. But these applications, they age, they may no longer work well in a modern world. They may be lagging behind comparable tools and features and convenience. And it just comes time to move. And when it becomes time to move, AWS is an increasingly common target, right? Even when you think about moving, though, you might be tempted to put that move off for as long as possible. It's often viewed as a risky or expensive distraction from your core business, right? But it becomes eventually a necessity. We need to think about moving to a more modern, more capable system, likely in the cloud, likely for us today, AWS. And hopefully while we make that move, pick up some business benefit, maybe some better reporting, some improved data quality. So the final straw for actually deciding it's time to tackle a migration up to AWS could be a variety of things, right? Your current data infrastructure no longer maintained. Maybe you have old OS or database versions that are bound to particular hardware. Maybe support for your current systems is getting prohibitively expensive. Maybe you've already started your modernization process, moved part of your infrastructure to AWS, and now you're sort of seeing an increased urgency to get the rest of it up there. Moving your applications and moving your data can be like a chain of dominoes falling. Moving one data set sort of necessarily precipitates moving the others. Maybe you're going mobile, right? That's often a driver for these type of moves, particularly in this post-pandemic era. Your data and its structure is fine, but you need more convenient portable access that you can get from AWS. Right? Now, moving on off-prem onto the cloud doesn't necessarily mean AWS, but I suspect for those of us today, we've already made that decision, right? Moving to the cloud, specifically AWS, there's compelling reasons to do that. On-prem infrastructure can get too expensive. You have to include the calculus for the hardware infrastructure and the physical space and the people required to tend it if you leave it on-prem. AWS infrastructure, more highly available, less susceptible to network outages, power outages that you might have to deal with when you keep yourself on-prem. On-premise security, always a concern. Again, complicated by more recent need to support mobile devices and needing to support our work from home staffs, right? And then, of course, there's a robust set of data-oriented services waiting for us up on Amazon. Things like S3 and block storage, databases and warehouses, a very rich set of places that we can place our data, right? So we'll talk about a variety of these things today. We'll talk about moving the data that drives our applications up to AWS. and where specifically in AWS. Likely a combination of bucket storage or file storage or specific database or warehouse technology, right? So we all, I think, are on the same, in the same place with the idea that it's good to move to AWS. We just need to figure out the most efficient, effective way to do that, right? Fortunately, and I suppose unfortunately, there's a wealth of tools available to help us move our data up to AWS. That's good news because we can choose a tool that matches our specific migration needs. But I suppose the unfortunate side is that it can be seen to add some time and complexity to your migration project, right? Because now you've got to take the time to not only migrate your data, but to figure out which tool set, from a wide variety of tools that you want to use, what's the best tool set for you to do your migration. There are lots to choose from. There's, of course, Amazon's own data migration service, which can be a very good choice for moving an entire database, including all of the related configuration and stored procedures, moving that from some relational technology that you have on-prem to some AWS provided database, right? And then you take Amazon's data migration service and combine it with their schema conversion tool, and you can do some fairly clever things in terms of mapping to a new schema, and even actually most recently start to do some basic transformation. As long as you're willing to write some JSON, do some basic transformation to the data in flight. So that's an option for you. If your data migration really is just a set of files, if you don't have relational sources or APIs to contend with, you might be able to get away with doing a migration with a simple backup and restore tool. Cloudberry comes to mind, which can move directories of files to either S3 or some block storage. Very simple, very economical way to migrate files just on their own. Maybe you have some data already in the cloud and in some common system, and your target system happens to be a data warehouse like Redshift. Then there's some nice cloud native warehouse loaders that you might want to consider. Example, Stitch is a good example, right? That can extract data from any most of the common cloud endpoints and then write to, say, Redshift, right, or Snowflake. And then another tool is a data integration platform, a full stack data integration platform that we think combines many of the strengths and capabilities of the other tools mentioned here. And it's our space, right? That's the context in which we come from. That's the context I really want to describe data migration to AWS using a data integration platform. So let me spend 1 minute introducing you to the platform, and then we'll look at some AWS migration use cases and examples. Right, so we are a data management platform, full stack, designed to facilitate migrations of all types, on-prem or in cloud, to a variety of Amazon services, right? Some of the specific competencies we think we bring to the table, we can help you when you need to move data that was generated by a custom application or provided by some vendor who may no longer be available or cooperative. We're very good at working with your complex legacy applications, even those that have been heavily customized over many years. We can help you actually do some transformation and cleanup of your data along the way. A migration is always a good time to clean up or improve data quality, removing cruft that may have accumulated over time, or slimming it down, only moving the data from your source systems that matter, right? The platform is a great choice for these kinds of migration projects because it is flexible, right? The platform can run on-premise, or it can run in AWS. It can handle a wide range of connectivity requirements, any flat file, any database, any API. We very good at dealing with complex scenarios and messy data. Very good at automating the process so that you can move entire collections of data in some sort of sequenced fashion. It's a low code environment, right? Not a no code, but we can design our pipelines visually using a palette of components. And I'll show you a few of those in a few minutes when we get to the examples, right? And then finally, we're going to be able to address the entirety of your migration, selecting which data to move, cleansing and reshaping it, validating it, and then confirming that all of it has arrived in AWS as configured and as expected, right? So I mentioned we can deploy anywhere. We can deploy CloverDX on-prem, or we can deploy it in AWS, right where your data is going to live, right? If you want to deploy us in AWS, variety of choices there, right? We've got a marketplace offering. So a few clicks and you can install the service straight into your Amazon infrastructure. You want to get more sophisticated, you can install outside of the marketplace in your own self-managed EC2 instance. You can use Kubernetes and create a containerized version, or you can even go serverless, right? And use Fargate to install our software in a way that you don't have to manage any infrastructure at all, right? So this is a wide variety of ways to deploy either on-prem or in the cloud, which leads to a decision point. If we're going to provide that flexibility, where do you want to do the actual migration process, right? You deploy our tool on premise close to your sources, right? And then we'll just push data up to the to S3 buckets, to file storage, to relational sources, or to some of the fancier warehouses, right? So we can deploy on-prem and push the data to Amazon. Or if you want to look at it the other way around, you can deploy Clover up in Amazon and then reach down on-prem and pull data through some ports you'll have to open, but we can do that as well. So we have that flexibility of deciding which side of the fence you actually want to execute the migration process on. And there's advantages and disadvantages to both, but the key takeaway here is that we're not going to constrain you to where you want to actually operate your migration pipelines, right? So with that, let's actually start talking about the migration process itself, right? First thing we need to consider really is, where is the data? Where's the source data, right? Might be on-prem, might be in another cloud. In some organizations, it's in both of those places. Regardless whether it's in the cloud or on-prem, the data itself could be stored in a variety of different formats or behind a variety of different infrastructure, right? Your source data may be files, XML or JSON, or even more modern formats like Avro or Parquet. Multimedia files, semi-structured or unstructured data, common to live in files. Your data may be in databases. Relational is traditional and usually fairly easy to work with, but there are other databases that are sort of newer generation, NoSQL databases, or even graph databases, right? So there's a lot of database technology, but commonality is that they're queryable, right? Usually through some structured language. If your data is not in files or not in databases, it may just be, actually stored behind an application, in which case you may not have access to the data store specifically unless you go through an API, right? And so you might need to make API calls to actually get to the data so that you can move that data to the cloud. So your source location, your source data can be in a variety of locations and in a variety of formats. And we need to be able to deal with that in our migration process. That echoes, sort of an equivalent on the target side. We know, of course, that our target's going to be AWS, but there's still similar sources, similar choices where we want to put the data in AWS. Do we want to put it in, keep our data as files in the file system? Do we want to put it into a relational store? We want to put it into one of the newer types of databases or warehouses, or do we have applications that are either already in the cloud or hosted by us that we need to make API calls to push the data as we migrate it into the cloud. Right. So I want to look at some of these arrows, some of the way we would build the pipelines to move data from these various locations and in these various formats. Right. So let's start with files. Moving files, data files from wherever our source is up to AWS, right? Immediate choice there as you move files to AWS is what file storage technology do you want to use? Real majority of us, I think, are familiar with S3 as a storage location for files. It's inexpensive, it scales. Implicitly to handle really large data volumes. You can write there in parallel. You don't have to be concerned about file locking. You do have to get used to the idea that there's no support for directories, and it's just, essentially a bucket with cleverly named files, but it is a very common place to push files from your source systems up to Amazon. Most of the data-centric services that are already in AWS, you don't have connections for or well-established interfaces for dealing with data in S3 in terms of maybe loading Redshift, or maybe putting messages on queues, or any other data-centric services. Most of them are well-equipped to deal with data that's on S3. You have another choice, though. You don't necessarily have to use S3 for storage of files. You may have an EC2 instance or a number of VMs, and you can simply mount either block storage or file storage, elastic file storage. Amazon offers a couple of different services there, right, which essentially look and act just like disks mounted to your machine. You need to have access to them, sometimes via SCP or FTP if you want to actually pull the files up there. If you decide to run Clover in the cloud, then essentially we can just treat it as a local target and write files there. Right. So choices when you move files up to Amazon. Now, when you're working with us in CloverDX, we have support for either of those file-based systems, right? And here on this slide is our first sort of preview at some Clover-specific graphics, right? These 4 boxes across the bottom of the screen, these are components that can be assembled to make data migration pipelines, right? We have a component that will copy files from some source location to some target location. Target can be S3, it can be SFTP, it can be a local disk, right? And the same with moving files. We can copy files or move files. We have components in our pipeline design tool that allow us to write new files, and we can write those directly to S3, or we can write them directly to mounted file storage, right? So we can write these things. We have a good story for moving files, manipulating files, creating files up in AWS, right? And so let's take a look at our first example then of a CloverDX data pipeline that migrates files from some source up into AWS, right? So this is a picture of a CloverDX pipeline, right? It was assembled in our design environment through drag and drop of these components onto a pallet. But it's not just a model. It's not just a pretty design. This actually represents executable code. This will run. And in fact, the screenshot I'm showing you is a screenshot of a pipeline that has already run, right? You see these little green check boxes up in the corner, means that the run was successful. Every component has a little green checkbox, which means they all completed successfully. We can see the amount of data that flowed through each section of the pipe as the data was migrated. Story here, we start with copying files from maybe some on-prem location to some staging area, which could be in S3 or it could still be local. But we moved them first before we began the process of migration. The migration process involves doing some transformation in flight, maybe removing, opening each file of a particular type, maybe just the CSV files you want to open, and maybe remove certain records that we're not interested in, maybe change some date formats or clean up some structures. Do something to operate on the records in the file before we actually land them in the target repository. And then once they're landed in the target repository, go ahead and delete what we've staged. If there were any errors in making the move of the files or transforming them, log those in some separate data store and send an email to say, hey, of the files that we moved, you know, these failed, and this is why they failed. Someone needs to go look at those and reconsider how we want to migrate them, right? So here's a CloverDX data pipeline for migrating data from some source system through a series of stages, and then ultimately arriving in some cleansed format up in either S3 or some other Amazon file storage. Right. Second example, a little simpler, but we want to populate a data lake up on S3, right? Our source, we're color coded in Clover, so green things are data sources and blue things are data targets. So here in this particular data pipeline, my sources are a couple of relational tables that I need to read. I want to migrate all my contacts, all my accounts. I want to join them together into one long sort of denormalized structure. And then I want to convert that into JSON structure and put that into S3, right? So from on-prem relational tables to a data lake as a JSON object in S3. The blue component, as I mentioned, is a data writer of JSON. It does two things for us, right? It structures it as JSON, but it also writes it into S3. You can see the target includes all the credentials we need to write to S3, including our secret key and our token, our bucket name, our file name, and then the structure of how we want to take the data that we've combined and write it into S3, right? Simple pipeline. Can be, you know, part of a larger process, but to give you a sense of what it looks like to design migration pipelines in Clover. All right, so away from files now, let's take a quick look at, you know, probably one of the most common places to move data from or to move data to, and that's relational databases, the Oracles and SQL servers and Postgres of the world, right? Very fortunate on AWS to have a rich place, a rich set of services for relational databases, factored really into two groups, right? You can rely on Amazon. Amazon's RDS database service will take care of everything for you, right? All of the infrastructure. If you want a MySQL or Postgres. Those are probably the two most common. It will spin it up for you at the right size. It will give you the right version of the software. It will do backups for you. It will do version upgrades for you. It can, if you need to, scale up to larger sizes. It's just full service. All you need to do is ask Amazon to spin a database up for you, and you just use it. That's not appropriate for you. You may want to take control and manage yourself, right? You can spin up in Amazon your own self-managed database, spin up an EC2 instance and install any database that you have the license to install, and configure it how you want to configure it. The choice is yours, right? And it's an interesting choice. It's not all most people, I think, lean towards RDS, but not always the case, right? If you're cost sensitive, I think you'll find, running an EC2 is probably going to be a little cheaper, simply because it provides less service for you, right? Less support. And that, you see the bracketed list of things that you want to do in a database down at the bottom of the slide, right? If you're dealing with RDS, right, really all you're dealing with is, what is the schema of your database and what sort of queries do you want to use to load and to query, right? Amazon RDS is going to take care of everything else, right? Your failover, backup and recovery, maintenance, the infrastructure, where it runs, it's going to handle all of that for you. Versus if you decide to want to go it on your own, really then the only thing that Amazon's providing for you is the compute power, right? The infrastructure, the machine on which you run, and then you're responsible for all of the maintenance of the database, backup and recovery, as well as the actual querying that you want to do, right? So you got a rich set of choices there. If you're migrating to relational in the cloud, do you want to manage it yourself, or do you want to use Amazon's fully managed database service? Doesn't really have much impact on the design of a migration pipeline. Clover, for example, completely transparent. In fact, you could shift back and forth between these if you wanted to make the decision downstream, right? When you migrate into an AWS relational database, the simplest way to think about it is just doing direct load via inserts, right? That's the simplest way to think about it. And it works well for moderate volumes. You can get into some issues with massive databases where it might make more sense to do bulk uploads. But for our purposes today, let's keep it simple. And I'll show you a pipeline that is just doing standard ETL, right? Extract, transform, then load the data into the target system, right? Whether it's fully managed RDS or otherwise, right? We're going to do the same design pattern, right? Might look like this, right? Again, green components are what we use to read data. Blue components are what we use to write data. This particular pipeline I envision would be running, on-prem, right? Close to my source systems. I want to pull data from an Oracle database, also pull data from some other system, maybe a flat file that's enriching data, right? Join that stuff together. In this case, I think it's media playout, list of maybe streams of media that have been played, and then some geotagging information about the source, right? We want to merge that data together, reshape it some, and then push it up into Amazon Postgres, right? Or maybe do two things with it, right? Push it up into Amazon Postgres, but also take that same combined data set, convert it into JSON, and write it into an S3 bucket. So I'm actually going to migrate my data into two places, into a relational store and into maybe a data lake for future use by other applications that might not want to go through a Postgres interface. Right. Okay, so that's relational. Let's move on to another common target when we're migrating data into AWS, and that's some of the specialized data warehouses. I'm thinking specifically of Redshift and Snowflake, not Redshift and Redshift. That second one is Snowflake. Those are, the two big players. Obviously, AWS has a preference for Redshift, but they have a very strong Snowflake story as well, designed to handle really large data volumes. These are columnar databases. But the best way to migrate data from your source systems into one of these, specialized warehouses is to use bulk uploads, right? Typically, these warehouses hold really large volumes of data. You don't want to use conventional insert logic, much more effective to do bulk uploads, right? Take your data from your source system, wherever it might be, copy it up into object storage, S3, and then once it's up into S3, use a Redshift or a Snowflake copy command to move it from S3 into the warehouse, right? And then maybe after it's in the warehouse, do some post-load transformation. You notice this is ELT, right? Not ETL, right? So extract the data from the source systems, push it up into S3, load it from S3 into the warehouse, and then afterwards, as the final step, do some sort of transform inside of Redshift or inside of Snowflake. Take advantage of the compute power that those two warehouses provide to do any sort of post-migration cleanup. Over pipeline-wise, it might look like this. Right here, I'm going to move some data from an on-prem relational, I think this is Microsoft SQL, into Redshift, right? And I've set this particular pipeline up with the idea that I might, need to run it multiple times, iterate over it, make sure I've got it, got everything complete. So it's designed to be restartable. It's designed to be configurable so that you can do it piecemeal, right? So what it does is it starts by reading a list of tables that are the subject for our migration, making sure that that particular table is a target if we actually want to migrate that table, and if we do, perform the migration and then keep a log of everything that we've done, right? This configuration file, it's just one design pattern, but it's nice, right? In this case, I've got 7 tables in my source system. I've enabled them all, which means I want all of them to be migrated. If there were other tables in the database, I could just modify this config file and the pipeline would work, right? It's schema independent. It's going to take care of everything for us, right? So this allows us to select which tables we want to migrate and interactively turn them on or off as needed as part of the migration process. So it supports incremental or restartable types of migrations, right? The actual migration itself, when we get to an individual table, we do this process, right? We read from the source table. Well, actually, we dynamically build the query because this is generic and it'll work for any table. We build the query that we need to read dynamically, then we actually read it, and then we write to Redshift using, you'll see this little squirrely bracket here. This is actually a Clover subgraph, which is optimized for writing to Redshift, right? So in this case, we had 50,000 records that we needed to push into our Redshift table. But we want to do that as a bulk process. So let me bust open this component and see what's actually happening with these 50,000 records, right? So if I open this component here, it's just another Clover, a package of Clover components, right? Here it is. Here, this is that Redshift writer. But when you explode it, what's inside of this looks like this, right? Take that set of 50,000 records and parallel upload it as fast you can into an S3 bucket, right? And so we did 2 times parallel. We loaded half into one file and half into another as quickly as we could. And we got those files up into S3. Then once they are in S3, we can build on the fly a load command, which will pull the data from out of S3 and load it into Redshift using the Redshift copy command. If we needed to do some post transformation, like cleaning up the temp files, we can do that, or we could issue another command to perform some post-load transformation inside of Redshift. Process for Snowflake, nearly identical, right? We're going to push the data to S3 files and then from S3 files into Snowflake. And in fact, the design of the pipeline doesn't change at all, right? It's just which component do we use at the end. Right. Then final pattern I think I have for you today is when your data is not in files or your data is not in any relational store that is sort of traditional, right? When we need to actually get it from APIs, increasingly common, even for on-prem sources, right? The data, our data sources may be controlled via API, or our data targets may be controlled via API, and that's our only access to them, or both, right? We may need to read from an API gatewayed data set and write to an API gatewayed data set, right? There are, this is simple here, right? The process at its simplest is when the target is API controlled, well, we need to read source data from wherever it is and then map that into an API call to load the target and then make the call to load the target. The mirror of that is essentially that. Make a call to some source system that will provide the data that we need via an API, map that from the API return into whatever our target system needs, and then write that to the target, right? Oversimplified, certainly. And there are things that you have to be concerned with APIs, like the latency, how much time it might take for the API to respond. Some APIs return paginated data, so you have to handle getting multiple pages of result sets. Some APIs throttle you based on load of the system or how many calls that you've made, so you need to manage that. All things that are possible via Clover. Happy to discuss that with you, but at its simplest, it is, as shown in these boxes here, reading, making API calls, mapping data to or from to create result sets or process result sets, right? An example, so final example I have for you today, moving data. In this case, the source is API controlled. Our only way to get to our source data is via an API, but our target is Postgres up in RDS, right? So these two purple components here, this one and this one, those are making API calls, right? This is healthcare data, make an API call data to get all of the data that the API will give me for my migration. It comes back as JSON, right? Need to pick that JSON apart, flatten it, do some validation, because there's only certain records that I want, do some conversion, maybe from English to metric units, and then write that patient data into a Postgres data table, but then also go back and get via an API call and get a bunch of enriching data that's also stored in that same application and write that to Postgres as well, right? If either of the APIs fail, log that, right? And make sure we know how to restart. If any of the data that we've pulled via the API is data that we don't like, either we've rejected them because we don't want that data migrated to the cloud, or because it's crufty, it's got bad, in this case, height and weight measurements, for example. So we're rejecting those records. We're not going to put them in the cloud. Instead, we're going to put them in the cloud, but we're going to put them in an S3 bucket so someone can come back and take a look at these and say, oh yeah, these records really don't belong in our Postgres just yet because they're a mess. So someone needs to take them out of S3 and clean them up before they complete their migration. Right. So message today, congratulations on thinking about moving or migrating to AWS. Rich set of services for you to store and use your business data up there. equally rich set of tools available to help you as you move your data up into AWS. And of course, we feel we're well suited for that task, as we could get data from any of your source locations and put it into any of AWS's data storage services. So we wish you luck on the migration project. Would love to talk to you individually about how we can help with your specific project, but also happy to take any questions that you might have now.
Thanks, Kevin. Yeah, I hope everybody found that useful. And if you do have any questions, do just pop them in the Q&A box, and I will throw those over to Kevin for some answers. Just while everybody's doing that, I just wanted to mention next week's upcoming webinar. So the same time next week, we have a session on migrating your data to Azure. So very similar to this one, but if you're looking at maybe different technologies, maybe you want to register for that and see what that process involves. And I will just put those links in the chat there. So you can go along and register. The other link there is cloverdx.com/webinars is our webinar library. So there you can see all our past webinars that you can watch on demand, and you can register for all our upcoming ones at any time. And if anybody does want to see anything in a little bit more detail, I'll also pop the link to our demo page. So if you do want a personal one-to-one demo, do just drop us a line via that page, and we can sort something out and show you specifics of anything you want to see and answer any sort of specific questions to your use case. So let me just check back and see if we have any questions. Kevin, we did have one question asking, are you using open source solutions for the CloverDX platform?
CloverDX itself is not open source, right? We're licensed software. Of course, we can connect to any open source data source or open source data target, and we can invoke open source data utilities as part of the pipeline, right? Maybe you want to do some encryption on the fly as you move your data up into the cloud, and you want to PGP encrypt. You can inject a PGP encryption call into your pipeline, and that's of course open source technology, and we'll just we'll leverage that. But our product itself is not open source.
Okay, cool. We have another question. I'm not sure this is enough detail for you to answer, but I'll try anyway. George asks, what about data lakes?
Well, I mentioned data lakes sort of in passing, I think in a couple of my examples. My personal experience, I guess, is a lot of people use S3 bucket storage as their data lake, right? And we've got a very strong story there in terms of moving record sets or files or multimedia, whether they're structured or unstructured, up into S3 data lakes, adding metadata as we go, naming them cleverly as we go so that they're easily, findable inside your lake. So when we think of data lakes, I'm commenting almost exclusively on S3.
Well, thank you. I think that's all the questions we have for the moment. Just give everyone a couple of minutes to put in any last minute ones. We did have a couple of questions, by the way, about the slides and the recording. So just to say, we will be sending this out via email. So that should be with you tomorrow in your inboxes. And we will put all these other links to sort of other webinars and demo requests and things like that in the email as well, if you do want to get in touch with us. So let's just have one final check back. And I think we're done for questions for today. So we will wrap up. So thank you very much, Kevin, for the presentation. We had quite a few comments from people who seemed to appreciate it. So thank you. And thank you very much to everybody who attended. It's great to see you all here. And we hope to see you at another one of our webinars soon.
Thanks, everyone.